Okay, so just I am formally asking you to allow me to record. So if you are uncomfortable with the record, you can tell me that I will not never post it into the public link, so you should be okay. So the coordinate system consists of two axes. Horizontal axis is known as the x-axis, the vertical axis is known as the y-axis, right? And if you go, for example, start from 0 and 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, back to kindergarten, right? Where you are counting the numbers, going to the right, going to the left, right? Going up, right? By unit. The units could be the units of measurement, such as it could be meter, kilometer, centimeter, millimeter, nanometer, certain kind of unit, but it's a unit. Every time you move left or right, up or down, that's the unit of the measurement that you're taking. So how you represent a point on this coordinate system is basically given by a pair of coordinate system here, right? This is pair of number. First x, like how many units do you go on the x-axis? And then y, which is how many times you go on the y-axis. So for example, over here, pi 3 means you go 5 unit, 1, 2, 3, 4, 5 unit to the right, 3 unit up, right? That's how it works. Simple, right? Look, if I can do it, you can do it, okay? Similarly, over here, this point Q over here is minus 3, 4, meaning that you went 1, 2, 3 unit to the left and 1, 2, 3, 4 unit up, okay? Our convention for physics 1 will be that anything to the left is negative. Anything down below this axis, for example, over here is negative. This is negative, this is negative, okay? That's our convention. Left is negative, down is negative. Does that make sense? So the length from point O to point P, when from, along the x-axis is 5 unit, along the y-axis is 3 unit, then the distance is given by Pythagorean theorem, where it is kind of like a hypotenuse here, right? So that's going to be 5 squared plus 3 squared square root. And let me call that r, suppose. So in that case, that distance is 25 plus 9 square root. That is 25, 24 square root, 6 times 4. This is 2 times 1.7. So that's 3.4, if it is in meter, about that. How much did you get? Alex, how much did you get?
I got 5.8.
Isn't that supposed to be a 34?
Yeah, it's 34 squared.
Thank you. Thank you. 34 square root is about 6. How much did you get?
It's a 5.8, but you can round it to 6.
Okay, cool. Thank you. Thank you, my friend. So, almost 6 unit. I made a mistake. That's good. Every time if I make a mistake, I would get a penny. I would be a millionaire by now. That doesn't happen though. Anyway, so this is a Pythagorean theorem, very simple. Okay, and this will come out handy again and again. Now, let's say that I found that measurement and I'm happy with this. Now, I'm also interested in another quantity in here, which is known as the angle over here. The angle made by the line OP, right? This angle can be calculated, and there is a formula for that. Logan, do you remember the formula for calculating angle here?
So is that going to be the sine formula, opposite over adjacent?
Okay, how do you do that? Sine of theta equals to?
It would be 3 over 5.
3
Sine 3 over 5.
Over 5. Not quite. Bryce, any help? You were almost there, Logan, but not quite.
I'm not really sure. I know it's one of the sines or tans, but I don't.
That's cool. Again, this is a class where everything happens in this class, stays in this class, which rhymes with Vegas, but Coco.
Tangent.
Catherine.
Yeah,
very good. No, this is good. This is good. Thank you for helping out here. We are all learning here, okay? So do not hesitate. So Catherine is saying tan theta equals to 5 over that almost 6 kind of thing, right? Or in other word, it's gonna be x divided by r, right? When I say 6, there is a little bit of crime happening, right? So some of you remember SOHCAHTOA formula from your high school? Olivia, do you remember that SOHCAHTOA thing?
I do, yeah.
Very good, very good. So what happens in that formula? You have, let's say that you have x-axis here, y-axis here, the distance r is here, and the angle theta is right here. Then it is given by sine of the theta equals to y over r. Is that right? SOHCAHTOA, right? Cosine of the theta equals to x over r, and tan of the theta equals to y over x. Now remember this, okay? This tan theta is also known as, this theta especially is known as the slope, okay? Tan theta sometimes represents the slope of the line here. The line that starts here goes up here. The slope is basically rise over run, right? This is the rise. Y-axis is the rise, x-axis is the run, okay? Theta positive means that you are going counterclockwise here. This is the most important part of my physics class, okay? Rise over run. Y-axis over here is the rise, x-axis is the run. Because the rise is positive, the slope is positive, okay? The rise is positive means that slope is positive. If my triangle happens to be like this, where my x-axis is here, and y-axis is here, theta is clockwise. See that? Theta is clockwise. Whenever you go from x-axis, theta is clockwise. In that case, it's going down. You're looking down, right? Just like our share market today in the GME, you know, it started high, going low, right? Started high, went low, it's falling down, right? Rise is negative. So rise over run, in this case, it's going to be, right? Rise in this case is negative, slope is negative. This is negative slope, this is positive slope, okay? Positive slope means that you will increase your y value when you reach there. Negative slope means that it's going to go down, okay? Does that make sense? Slope means rise over run. Slope is the ratio of rise over run. This is the rise, this is the run, y-axis is rise, x-axis is run, and that gives you some sense of geometry here on how to calculate the angles. Everybody clear on this one? Please stop me and ask, okay? If you understand this one, you will be happy with so many problems. Keiko has a question. Koku.
So are these the only ones we need to learn? Because when I was doing 190, we had the cosecant and others. Are these the only ones we need to learn?
There will be a few more. I will, you know, try to blow your mind by doing a couple of things here. But you know, this is the basic, you know, physics at its core is geometry. If you understand the geometry, you can understand physics. That's my philosophy, okay? Math is just a tool, right? Okay. All right. Very good. Any other questions here? Koku, you had a question?
Yes, and also we need a physics lab book.
No, I will provide you the manual. You don't need to buy the lab manual. It will be provided to you for free on Blackboard. Thank you for asking that. And this will be related to your lab later. So this is like think of this like a workshop today, okay? Our lab workshop. All right, so this is clear as mud, right? Everybody understood this part. This geometry excites me, that's why. Sine theta, cosine theta, tan theta, the Pythagorean r square equals to x square plus y square. This is the formula of the day, okay? Take a formula sheet, start writing this formula before you sleep. It almost rhymed. It almost rhymed. Okay, back to our geometry. So this is the formula that we will be talking about, okay? Y over R is sine, X over R is cosine, Y over X is tan, and that is our basic geometry. Pythagorean theorem, we already know. We okay with that, right? Now, because we know these basic things, I wanted to like go into writing mode again, but all right, here we go. Over here, this is my Y, this is my X, this is my R, this is my theta. You know, I'm not worried about finding my X because it's right here. Okay, that was supposed to be joke, but okay, it did not work. I can see that. All right, I found my X over here. Okay, that. So we know that Y over, right, R equals to sine theta. Therefore, Y equals to R sine theta. Okay, from geometry. If you know R, if you know sine theta, you can find Y. Similarly, X over R equals to cosine theta means that X equals to R cosine theta. It comes from the same basic geometric fact here, okay? And in few minutes, you will see why I'm doing this. You will see this why. This is not a new formula. It's just derivation of whatever we have up here, all right? Y over R equals to sine theta, X over R equals to cosine theta. The basic geometric fact gives you the way to find Y or X value, right? Suppose you know this R, and suppose you know the angle, right? You can find X by doing R cosine theta. Suppose you know R, you know theta, you can find the value of Y by doing Y equals to R sine theta. And how do we get that? That's from the geometry. Is that clear, everybody? This is very important, okay? These are called the components. Okay, I'm going to talk about that next. All right, very good. Now let me give you one problem, quickly, and take this as the quiz for today. Okay, you're gonna calculate in your calculator, and then you're gonna type your answer in your chat. Do not enter until I say go. Okay, just calculate, type in your answer, but do not hit enter yet. If you have a triangle, okay, so suppose this is 3, this is 4 meter. What is the value of the angle? Suppose I made a right angle triangle. Okay, this is 90 degree here. This is an angle theta. This is a right angle triangle. This is 90 degree. Okay, that's one of the requirement of the Pythagoras theorem, right? The one of the angle has to be 90 degree. So if this is 3 meter, this is 4 meter. What is the value of the angle theta? All right, do your calculations. And whenever you are done, give me a thumbs up. So the answer we know, right, is 53.13, and we take the tan inverse of 4/3. The setting on your calculator must be in degrees if you want it, the answer in degrees. So this angle you can calculate. Very good. Awesome. Good job, guys. All right. So again, let's jump one more time. This is my coordinate axis, X axis, Y axis. We're still doing geometry, okay? Geometry, because next thing that we're gonna do will help, solve our problem. All right. So this is a coordinate here. Let us suppose the coordinate is 6, 6, okay? The coordinate of that point is 6, 6. What will be the angle? So it'd be easy to do. Kia or Kaya.
I'm not sure, but I know we have to
I can tell you are on the right track. Again, the question is that in your coordinate system here, the OP is the length of the line segment here, which is making angle 60 degree with the x-axis. What is the value of x here, the x component or x side here, right? This is a right angle triangle right here. That's your 90 degree, right? This is 60 degree. How much is this x? How much is this y? These are two components or two sides of the triangle that we are making. If you have an answer, please feel free to volunteer, okay? So for this problem, you have x-axis horizontal, y-axis vertical. This angle over here is 30 degree, OQ. Now you want to find the y and the x component of this, system here. If the length OQ is 10 centimeter, okay? And then let me say that this is OA and this is OB. What is the length of OA? What is the length of OB? All right. So there are two kinds of quantities, vectors and scalars. Scalar quantities only have the numbers, only numerical values, right? But vectors are different kinds of quantities that we will be using, which have both the magnitude and the direction. Magnitude as well as the direction, okay? It will tell you about where it is going, right? And how much it is going, how long it is, and which direction it is going. It's especially useful when you are navigating a system. If you are, using Google Map to go to your friend's house, it's like turn left, turn right. In half a mile, take a U-turn, something like that, right? It's always telling you the magnitude of the length you have to go and the direction you have to take. Displacement, for example, force, field, right? Acceleration, those will be the examples of the vector quantities that we will be using. Whenever we are using vectors, we will have to report both the magnitude and the direction, okay? Magnitude and direction. Scalar, only magnitude. You measure the length, right? That's your scalar. You measure the temperature, that's your scale. Basically that's your scalar. If you measure the energy value, that's going to be your scalar quantity. They don't have any directions, but there are vector quantities that we will be using the next. Anyway, so if you are familiar with the Lancer, our, the mascot, they have an arrow on it. So I feel like he is a vector. Okay, that was a joke, did not work. So basically you have magnitude and direction, right? So if you are looking at arrows like that, these are basically representation of the vectors. The nice thing about vector is that you can take a vector and transport it using, some kind of system. So let us suppose that this is your vector. You can copy that vector and move it around without changing its direction. If it is facing the same direction and it has the same magnitude, same length, you can basically move it around. It doesn't change its nature. As long as you keep the same length, same angle, the vector is the same. Vectors are represented by arrowhead like this, arrows, and they have the length that represents the magnitude of whatever the quantity we are measuring, and the direction, right? The angle, right? So it has the length and the direction that we represent. You can move it around. You can put it in your pocket. As long as you do not change its direction, it's going to be the same vector, okay? How do we add the vectors? The vector can be added in different ways, okay? And what does it mean to add a vector? Suppose you wanted to go from point, let's say this is your starting point, and you went this way, right, for some distance, and the way of this way for some distance, and you moved around this way. Suppose you went there. So at the end of the day, you wanted to find how much did you go, right? Then you can find how far you went, which direction you went. Then you can add up the vectors here. All of these vectors added up gives you the vector addition. It has the angle, it has the direction, it has the magnitude. Okay. Remember that simple algebraic mathematical addition, for example, 3 plus 4 equals to 7 does not work in vector. If you add 3 plus 4, it becomes 7. But if the vector A is 3 unit with angle, right? And vector B is some, let's say 4 unit with some angle, then A plus B is not gonna be 7, right? That's what I started the class with. If you remember, I gave you 3, or I think I gave you 5 and then 3. I added them together, it was not 8, right? It was something else. You use Pythagorean to find those guys, okay? So the vectors can be added by, let us suppose there you are adding vector A with vector B, okay? There is vector A, there is vector B. You can add the two vectors by joining the tail of the first with the head of the second. This is your vector addition, okay? Again, if you wanted to join the vector, suppose you have, this is my coordinate system, and then let us suppose that you have a vector A this way, and then vector B this way. Then sum of the vector A plus B is given by joining the tail of the first with the head of the second. That is vector C, suppose. Then that's gonna be my vector addition. There is whole geometry that we need to take care of. In a second, I will come to that one, okay? We will be taking care of the vector addition by using the geometrical concept. Is everybody clear on this one? The way to add the vectors is joining the tail of the first with the head of the second. Tail of the first to the head of the second. C vector is your addition vector. Suppose your vector A is this way and vector B is exactly the opposite way, right? Then A plus B equals to C. If A and B are equal in magnitude but opposite in sign, meaning that one was going to the east, another was going directly to the west, that is called negative vector with the negative sign, meaning that you just flip the direction 180 degree, right? So that vector will be 0 vector because it started from here, right? And then it came back right there. An example is the displacement. You started from a position, you went all the way to the, let's say, Kruger, and then you come back to the same position. Your displacement, you did not move at the end of the day. So your displacement vector is 0. At that time, the result of the sum of this vector will be 0. Okay, this is called negative vector. You can always, add the vector using this simple vector addition formula here. And subtraction is the same, right? Now A minus B equals to C. If you do that, right? Basically what you're saying is over here is that if you subtract the vector, you basically take this B vector. This is your B vector here, right? And then when you say minus B, you're gonna flip its direction. Does that make sense? If your vector X is this way, minus X will be the opposite way. Same magnitude, just opposite direction. That's the minus vector. Okay? That's all. All right. How is this going to be useful? Right? How is this going to be useful for our physics class? Let's look into that. Now, if you look into the vector quantities like this, for example, you have a vector A. Now we will go into a little bit details of the X and Y component, okay? So if you look here carefully, this point is going to be, X comma Y, for example, right? the tip of that vector A. What happened here is that you went X quantity, X unit on the X axis, Y unit on the Y axis. So they look awfully similar to what we have been doing for the last 45 minutes or so, right? You went X unit to the right, Y unit to the topward direction. There is an angle there, theta, and your vector A is here. So any vector A can be represented as the sum of the component. You see that? This is vector AX. This is vector AY. There we go. Why AY? Because this is the Y component of the vector. You can think of component as the shadow of a vector. Suppose on a sunny day, you are standing up on the ground, right? So why am I having a hard time getting that thing here? All right, here. So there is a sun. Summer is coming, so there will be sun, don't worry. And then this is you, very happy because you learned physics during the winter semester, right? I mean spring semester. Very happy because you're on the sun. Now this is your shadow. I mean, somehow your shadow is green here, right? This is you. This is your vector A. And then this is the angle that you're making with the ground. See the shadow over here? The shadow is actually your component, X component along this horizontal axis. Think about it. Your shadow is your component. So you can represent these component AX as like if you put your light bulb here, the shadow will be on the X axis. If you put your light bulb over here, your shadow will be on the Y axis. So these components act as the perpendicular shadow on two different normal axes here. X component is given by the shadow of vector A along the X axis. Y component is shadow of the vector A along the Y axis. If you look into the geometry again, you see that X and Y component can be found by simple geometry here, right? AY in this case, because of the angle here. If the angle was over here, then that will be different case, okay? Because the angle is over here, AY is gonna be A sine theta. Because the A is there, theta is there, AX is gonna be A cosine theta. These are two components of the vector A. Again, if you know AX and AY, then the magnitude of the A represented by this symbol here, right? Vector A is represented by A with the arrow on its top, right? Magnitude is represented by 2 bar sign here. The magnitude of the vector is given by Pythagorean. Okay, this should look back to what you have learned until now. You have now come back to a full circle where you know the Pythagorean theorem, you know the geometry, you're finding the X and Y component of a vector given the values of this magnitude and direction. Everybody okay here? Jennifer, are we good? Is it making sense? Very nice. Okay. Now let's go a little bit deeper. All right. Let us consider that there are two vectors, okay? There is a vector A which has the component AX, right, and AY. These are two vectors here. And there is a vector B which has BX and BY, right? So if I were to draw this, it would look like something like this. This is vector A. It has two components here. AX, the shadow on the x-axis, AY, the shadow on y-axis. I have another vector B, could be this way, right? This is BX, happens to be negative, but you know, vector is a vector. And another is by. That way. The addition of the vector A with the vector B is given by ax plus bx. So you add the vector plus ay plus by added together. So you would collect the x-axis component, add them together, whatever comes out in terms of the number, okay? Number could be anything. You add again the So you had the vector A, which had ax, ay. You had a vector B, which had bx, by, right? The total vector will be add the x component, add the y component, right? These two added gives me, let's say, you know, vector C is sum of the vector A plus B. And I will give you another example to clarify this, okay? This add gives me C vector is Cx plus Cy, where Cx is Ax plus Bx. Cy is Ay plus By. Add the x component, add the y component, everybody is happy. Okay, I'm going to come back to this one again, okay? Stop me if it is not making sense. All right, let me give you a demonstration of how this works. Are you guys good here? Doing okay? You will survive? Okay, all right. Let me see. Can you guys see my screen okay?
Yeah.
Okay, thank you. I needed to hear those confirmation at times, you know, because I'm like, am I the only one talking here? Okay, so I'm using a paid sim that will be part of your, you know, demonstration and lab sometime later. But I just wanted to give you this demonstration here. You know, there are vector A, B, and C here. You can drag it around here. See that? So I'm putting the vector A, okay? And you can have the component, you can, you know, twist it around. And you can see that if you have a vector A and the angle is 45 degree, right? The magnitude of the vector A, the length of vector A is 21.2 centimeter, for example. Then in that case, X component will be 15 centimeter, Y component will be 15 centimeter. Do you think that you just did those kind of things, right? If you know A, if you know the angle, you can find the X component, AX, and you can find the Y component, AY. Do you guys agree with that? Make sense? Everybody cool? All right.
Yeah.
Thank you. So in this case, you have a vector A. Let's put another vector B. Okay. And just for the hell of it, I'm going to make it a little bit different. The vector B. The magnitude of the vector B is 25.5. The angle it is making with the x-axis is 11.3. Therefore, the x component of the vector B is 25, which you can obtain by doing B cosine of the theta. By is pi, B sine of theta. You can do that. Now you can add these two vectors in many ways, you know. So let me put the components here first, okay? If you wanted to get there, you have to go AX, AY. Similarly, BX, BY, right? And if I wanted to put the values there too, you know. Now, sum of those vector A and B is given by, right? This is your sum vector, okay? The total sum, which is given by addition of the X components. See, this is the first vector A. Stop me if you don't get it, okay? Because this is important. This is the sum, this is the X component of the A. which is 15. This is the y component, sorry, x component of the b, which is 25, right? So when you add 15 plus 25, the total value of the a plus b will be 40. Does that make sense? Does that make sense? You
Yes,
have
sir.
vector, you have vector a, you have vector b, right? It has the angle, and you have the component ax, sorry, x component and the y component. Oh, sorry. So let's see if I can write it here. Okay, so you have theta. So this is the vector here. They have the theta, you have the x component, and you have the y component, right? So for a, the x component is going to be ax, which is 15. For b, the x component is going to be 25. So sum of the x component is going to be 5 plus 5, 10, 2 plus 1 plus 1, right? 3 plus 1, 4. So the x component of these two added together gives me 40. Similarly, for y component, ay is 15, by is 5, right? Ay plus by is 20. Therefore, the sum of these vectors s, right, this s has the x component sx, right? Sx equals to 40, sy equals to 20. That's how you make this sum component here, right? Your vector that comes out over here, which is the sum of those vectors, is going to be given by the sum of the x and y component. Everybody clear on this one? Very good. If you understood this, half of your trouble in physics will go away. I can tell you that. Okay? This is it. This is it. All right, let me stop here and allow the questions. Are you guys, yes, Koku.
So will there be a time where we are going to add angles to the numbers to make the component whole, like an AX, we will include an angle, not only figures?
That's a really good question. Okay, let me see if I understood your question. Let's see. All right, so your question is that will there be a case where you have a vector and the angle and you will be calculating the components? Did I understand it right, Koku?
Yes, sir.
Okay, that's really good, because that's where I was going to go next. And then after that, I will let you go home. I don't know what happened. Can you guys see my screen?
No.
No.
How about now?
Yes, we cannot see.
Yes.
So I have shared my screen. If you can see, that would be great. Okay. Here is a real test of whether you understood this problem or not. Okay. Let us suppose that we have vectors which look like the following. Right? This is x-axis, this is y-axis. Your vector A has the magnitude of 5 meters with the angle of 60 degrees. Okay. You have another vector with the magnitude of 5 meters with the angle 60 degrees with x-axis. Suppose this is vector A, this is vector B. And there is another vector C, okay? This is again 60 degrees, okay? The magnitude is 5 meters, okay? The question is, what is A plus C? What is A plus B? And what is B plus C? Okay. Take a screenshot of this, please. If you have to take the screenshot, take a screenshot of this. So you have vectors there, A, B, and C. I want you to find the values of the sum of A plus C, A plus B, B plus C. The easiest way to do this is by constructing a so-called vector table, okay, where you would put the vector and then the angle, the x component. Let me say, oh no, made a mistake there. The PowerPoint somehow cannot retain it, so I'm going to draw it again. My apologies. So this is my A vector. You know, the length is 5 meters, the angle is 60 degrees. This is my C vector. The length of the C vector is 5 meters, the angle is 60 degrees. And then there is my vector B with the angle 60 degrees. Right? This is 60 means that this is going to be 30 degrees. The length of the vector B is going to be 5 meters, same thing. Okay? What I want you to do is construct a vector table where you have the vectors A, B, C, the angles with the x-axis, okay? And then x component and the y component. Make a table, and then this will be your AX, AY, BX, BY, CX, CY. I'm writing the letters, but you will calculate the angles are given. You will calculate the values here, and the values will have positive or negative values depending upon whether it is going to the left, up, down, or right, you know, depending upon that. I'm gonna do it as a group setting here. The question is find A plus B, A plus C, B plus C. What is the value of, what will be the value of these three cases? Okay. All right. I'm going to divide you in the group. The way to do this is each person takes care of one vector, A, B, and C. Find the component. You can share your screen in the group, okay? If you are working on a computer. And then find the value of the component AX, BX, CX, AY, BY, CY, and then add them together to arrive at an answer. Should not take more than 6 minutes, you know, but nobody is looking at the clock. Kwaku?
After sharing, after putting us in the groups, are we still going to see the image you drew?
No, that's why I want you to take bring out your phone, take a picture or do screenshot, whatever you need to do, record it on a paper, do something, you know, because you will not be able to see this screen on your group. That's one thing Zoom doesn't allow. So take a screenshot. Hopefully you have drawn that on your copy, on your paper. Feel free to take a screenshot if you need to. Everybody ready? You guys excited? Is it a bit shocking that I gave you so much information on the first day? It's like, come on, be merciful, you know, it's like. But, you know, today's pain will pay off tomorrow. I can tell you that. I said that on when I was on the recording. Okay, well, what happens in this class stays in this class. So don't post it on TikTok. Ready? All right, I'm going to open up the room. Go to your room and work with your friend to solve the problem. A plus B, A plus C, B plus C, okay? See you in a few minutes. If you need help, call me out. All right, the question is, how do we solve this problem, right? So we have the x and y component that we can calculate by using the vector identity that we have learned. So let me try to solve this with enough hints so that you can go ahead and then try this problem, okay? And this kind of problem will repeat, so it's worth looking at it again and again. All right, so I'm gonna start first here. We have drawn a vector table, right, where we know the x and y components. So basically what we're gonna do is we're gonna write down the vector table here. So let me start by drawing this table. Suppose my vector A, right, had the magnitude of 5 centimeter. The angle it made with the x-axis is 60 degree. Then in that case, AX will be, right, this is my vector A, making an angle of 60 degree with x-axis. It's gonna be AX is A cosine of 60 degree. AY is A sine of 60 degree. Okay, A cosine of 60 degree is, cosine of 60 is half, so that's gonna be 2.5 centimeter. A sine of 60 degree 0.8, so that's gonna be, A is, the magnitude of A is 5 times sine of 60, 0.8, so that's 4.33 centimeter. Okay, this is my x component of the A. Similarly, if you look into the picture, you will see that B also has 60 degree with x-axis, right? And also C has the same value. But the difference is that A is along x-axis. So A was along this, first quadrant here. So AX will be positive and AY will be positive. Whereas for B, although the component values will be the same, the BX will be negative because it's to the left. Remember Beyonce. BY is up, it is positive. For C, right, the vector C, right, the angle is same. Luckily, we have the same value here. So CX will be along the same, positive x-axis, whereas CY will be pointed downward. So we have the values that is going to be, 2.5 and 4.33 along the x and y axis for all of them. But on your vector table, you have to be careful now, okay? Whenever you draw the vector table, see this AX and BX, they are equal and opposite, right? AY or BY and CY are equal and opposite. So whenever you add, let's say vector A plus vector B, then what's going to happen is that your AX plus BX is going to be added together. That's along the x-axis, plus BY plus AY will be added together along the y-axis, right? So if you look into your table, A, B, right? And then you have the AX, AY, X and Y component written there, right? X and Y component written there. This is 2.5, 4.3. BX is negative, BY is positive, right? So when you add these two guys together, when you add the X component together, this will cancel. So let us suppose vector C is sum of those, then CX is going to be 0, CY is going to be twice, 8.6. So that is your vector sum, okay? You can write that as either the combination 0, 8.6, or you can say it in terms of the unit vectors, okay? That we're going to talk next. But this is your vector C. Oh, no, I already have C here. So let me call that vector X. I should call them vector P. for whatever reason, P is Px and Py. Sorry about that. Px is 0, Py is 8.6. You can find the magnitude of P, right? And the angle for the P by using the Pythagorean, but that, you know, we are not going to calculate that for now. We're just going to calculate the value of the x and y. So now what we end up doing is that we have ax and bx and cx, right? Similarly, ay, by, and cy, right? These are the values that we have. When you add, let's say the vector p is a plus b. When you do that, you're gonna add the x component of a, right? Ax plus bx, right, will be px, and py, vector py will be by plus ay. That's the vector. So in this case, as you saw from the value there, right, a was this way, b was this way, negative bx, positive bx, ax, they cancel out. So this is 0. Py is going to be 4.3 plus 4.3 is 8.6 centimeter. So this is your sum of the vector. Similar goes for, let's say, b plus c. Let us suppose that b plus c equals to vector z. Okay, in that case, you're going to add the x component and y component of these vectors, right? So in this case, the gx will be bx plus cx. Gy equals to by plus cy. So you add the numbers here, okay? Bx, because it is going to be, you know, the vector b is along negative x and positive y. So bx is negative, right? But cx is positive. So that's going to be 0. They are equal in values. You can calculate. Similarly, by is positive, but for vector c, cy is negative, and their values are equal and opposite. So that's going to be 0. So therefore, the sum of this vector b and c will be vector 0 plus vector 0, meaning that if we say that the sum of the vector b and c is vector g, then in that case, gx is 0, gy is 0. So it will result into a 0 vector. Okay, do the math. Let me know if you have problem. Reach out to me. If you have questions by email, I'll be more than happy to sit down with you. Okay, all right.